What I'm going to be talking about here is the relationship between the kinds of investments that you've been talking about here today and the future of the economy. And the connections I would submit here are extremely tight. But first of all, I'm going to be moving then through four major points. One of them is that this is a field where public investment and private investment are intimately connected. It's a place where regulatory policy is going to be a necessary part of the investment environment of everybody working here, for two extremely important reasons. One is that we have to deal with the hidden costs of petroleum imports, which could be very high. And second, because the potential cost of climate change is not embodied in the current price of energy. This is going to require a very wise and difficult debate about how to mix private and public incentives. But the good news is that the kinds of technologies that you are talking about provide really cost-effective opportunities for meeting these challenges in a way that satisfies both public and private interests. And the kinds of investments you need to make to exploit these opportunities are precisely the kinds of investments that you need to drive productivity growth, innovation, and competitiveness throughout the economy. This is a place where if we do this right, we can actually put the U.S. in a leadership position in many key areas of technology and come up with policies that drive innovation broadly through the economy, as well as provide cost-effective solutions to the energy and environmental challenges. So just to take a very brief look at the public policy challenges, obviously one is the blunt fact that the oil prices are almost certainly going to go up, perhaps a lot. It is true that there's a lot of oil out there to be had. The bad news is that it's often hard to get and expensive. A lot of it is in places that may not be terribly friendly to U.S. interests. The second, of course, is climate change, and this is an issue over which there is absolutely no serious scientific debate. What I'm showing you here is the results of, first, the dark black line showing you the actual historic trace of temperature over the last 100 years. And the blue is an attempt to explain it using all known natural phenomena. This has got volcanoes. I should have added a more recent volcano here, but it's got the eccentricity of the Earth's orbit, precession, sunspots, you name it. Everything that we know how to anticipate through the natural cycles, you can't explain the phenomena that is actually occurring. If, however, you add human activity, the prediction is very sound. And obviously these models need to be improved. There are problems. There's rich scientific debate. We'll identify them and fix them. But anybody who challenges this central thesis of the community has got not only to find, not just to pick away at tiny pieces of this, but come up with some alternative explanation for why this phenomenon is occurring. There just is none. So the fact is that we're going to have to address this issue of climate, and there are basically three choices we've got. One is to try to prevent it, or at least slow it. The second is to try to mitigate the changes that are happening by adjusting agriculture or digging more canals or putting up dikes. And the third is just paying the price in suffering, people having to move, people having to have a harder time growing food. Now, personally, I prefer the first. We're probably going to have to do all three. But I'm going to concentrate on the first, of what we can do to offset or at least minimize the impact of climate change. And the two investment streams that I'm going to be talking about begin with the demand for energy, and then I'm going to talk about the renewable energy supply. Now, this is where the energy goes. This is where the opportunity space is. This is where the U.S. energy went in 2009. In order to find a way to address efficiency, you have to look everywhere in the economy. And this opens up a fascinating set of research problems. It opens up probably every behavioral, economic, and policy problem you can imagine, but it also is an incredibly target-rich environment for innovation right across the scientific and engineering spectrum. So I'm going to roar through these just to get a view at 30,000 feet, and then I hope we can spend some more time talking about it in question. Buildings are a very big deal, 40% of all energy, 74% of all electricity. It keeps growing because industrial use of electricity keeps going down, and residential and commercial building use keeps going up. Essentially, the electric utility industry of the United States powers buildings, and you can see most of it goes into rather mundane things: heating and air conditioning and cooling, lighting. One of the more troubling aspects is that the other category is growing faster than anything else, but each one of these places represents an opportunity. But one of the things that has been very difficult to address is that the construction industry itself doesn't behave like a modern production industry in that it doesn't actually do a lot of research on its own about how buildings operate as systems. This is something that we have tried to address very strongly. You probably see that we have a proposal for a research hub at a university that will focus exclusively on how buildings operate as systems. And this means not just how all the pieces fit together, but how the sensors and controls and management software will affect the performance of a whole building. If the new construction industry does very little research, it's even more confused in the business of retrofitting existing buildings. And one of the things that you have to confront if you're saying we're going to try to meet the kinds of goals that President Obama has set for us, which is an 83% reduction in greenhouse gases by 2050, you simply can't get there from here without doing something extraordinary with the existing stock. The fact is, though, you can do a lot with the existing stock, but there's really no business enterprise in place that can operate at the scale and with the sophistication that you need to address this problem, something we desperately need to fix. Now, in addition to the building systems, there are building components. A lot of you are probably familiar with the story of what can be done through technology with the right incentives in this place. Refrigerator standards, what happened was you get an enormous decrease in the energy use of refrigerators, while at the same time refrigerators got larger and cheaper at the same time. This is sort of a classic example of what you can do if the incentives are right. And you get the imagination of the community focused on it. And of course, we're nowhere near the theoretical limit. But this is, here's another example of a technology that has just come into the marketplace, helped in part by stimulus funding. This is a heat pump water heater that General Electric is making in a new plant in the U.S. It just started producing in the U.S. More than a factor of 2 improvement over conventional electrics. One of the dilemmas you see both in refrigerators, in this device, and in new air conditioners is that they all use refrigerants, and we have cleverly moved from refrigerants that damage the ozone layer to refrigerants that are greenhouse gas problems. You'd like to be able to get to a point where you don't need refrigerants, completely solid state chilling, and we have a bunch of advanced research money we were able to put on that problem, again, thanks to the stimulus money. Lighting is another huge opportunity, I think around 15% of all electricity. This is a company that got stimulus money and is in production in Durham. It's approaching 100 lumens a watt with the technology that's actually commercial. This is, again, nowhere near the theoretical limit because for pretty good white light, you should be able to get above, the theoretical limit is like 350, 380 lumens per watt. Now, one of the things that has driven progress in this area traditionally has been appliance standards. You saw that what happened in the case of the refrigerators. They've been moving along at a pretty slow pace for the last 15 years. One of the joys of taking my job is we walked in facing 23 court orders to get on the ball and get more standards out. And we did it. I mean, we are now operating at almost twice the rate of the past 15 years. And we're determined to continue that. It turns out we have a lot of authority within existing statutes. We're probably going to get more through the bills that are coming up, including areas like lighting, televisions, and other areas. Now, I said that one of the key things we need to do is to find a way to build an industry capable of going to scale on retrofits. People said that the president was crazy for saying we could retrofit a million buildings in a year. It's probably going to take more like a year and a half. But the fact is that there are on the order of 120 million homes out there. So unless we're going to spend 120 years doing this, we've got to go to scale. There's 70 billion square feet of commercial building space. How do we create an industry that's capable of managing an operation at that scale and operating in a sophisticated way with continuous improvement and driving costs down? Well, we've got several programs. One of them is this retrofit ramp-up competition, which we'll hope to be announcing the winners of this very soon. It's basically a competition challenging communities to invent ways that can sustainably drive retrofits at scale. Homestar is another major piece of legislation that's now passed the House, moving to the Senate. We're hoping it'll be part of jobs legislation. Again, trying to find ways of funding retrofits at a scale appropriate to the challenge in front of us. Turning briefly to industry, this is an area where the investors are more sophisticated than construction in most cases. They have been making steady improvements. It's a complicated enterprise involving a lot of different industries, though only about 5 or 6 of them account for most of the energy consumed today. But in spite of all the advances that have been made, we're nowhere near the theoretical limit of what these industrial processes can achieve. And this compares what the U.S. has done with the state-of-the-art, what our people think are the maximum practical efficiencies, and of course, sort of the thermodynamic limit, the maximum possible. And you can see that the U.S. is way short of the state-of-the-art, and certainly way short of the maximum practical in almost every major industry. So the opportunity space here is very, very large. And we're trying to build up an effort that is capable of moving us rapidly towards these efficient production. This is something which we hope will be able to drive U.S. productivity broadly and put us in a competitive position worldwide. And we're thinking about sort of 3 buckets of activities here. One is how do you make conventional stuff more efficiently, which is to say, how do you make steel and cement and glass more efficiently? Second, we have a big focus on how do you make energy efficiency and renewable energy products efficiently? How do you drive down the price of manufacturing lights or manufacturing photovoltaics? And third, looking at alternative materials. Oysters do a very good job of making something that looks a lot like cement, and they do it at room temperature. Are there ways that we can start shifting to titanium instead of steel, to carbon fiber, to some of these new materials that may have lower embodied energy and provide the same services? Again, the country that figures out how to do that first is going to be in a commanding position. And they all have direct and huge benefits in energy efficiency. Transportation, dominated, of course, by petroleum. This is the figures I'm showing you, by the way, are the baseline. I'm showing them to show that the baseline assumptions from our Energy Information Administration show that everything is going up. If you're going to hit the president's goal, most of these things are going to have to be going down. We're pursuing 3 thrusts on transportation, light-duty transportation. We're trying to find alternative fuels for conventional spark-ignited and diesel engines. We're trying to move very heavily towards electrification, hybrids, plug-in hybrids, and all electrics, and then looking at fuel cells powered by hydrogen and perhaps other fuels. It's not completely clear who wins this fight, this market race. It's very likely that in the future you're going to have a much more diverse set of vehicles on the road, perhaps specialized for different purposes. But one strategic question here is there are at least 3 alternatives for light-duty vehicles. There are other places where you don't have such alternatives, like aircraft, like heavy long-distance trucks. And it may well be that it makes sense to take, since we have sort of a finite reserve of biomass, roughly 1 billion tons a year seems to be the maximum we can produce using conventional means. How do you want to use that and put it to its highest use? And it may well be that aircraft fuel, diesel fuels for trucks is a good market for that. We have actually started working with NASA on a green aircraft initiative. NASA has very ambitious plans for getting 50% or more reduction in fuel use by aircraft, and driving down the demand to the point where we could provide a very large fraction of it with biomass fuel. But what has been really new in the stimulus has been an ability to put a lot of resources on hybrids, plug-in hybrids, and electrics. Several $billion have been invested across this supply chain, from looking for the material to building the cells themselves and recycling the product. And you can see our appetite here is very large, trying to hit 500,000 batteries a year in 2014. This would be a serious contribution to a serious change in the infrastructure of the automobile industry. It has certainly driven a lot of new investment in the production of batteries and associated electric vehicles, and generated a lot of excitement certainly in the manufacturing enterprise. What we're producing now, of course, is not the end of the line. We think we can get from roughly $800 a kilowatt hour, which is the current price of a lithium battery, down to $300 a kilowatt hour with the technologies that are in the pipeline. We can go even further. The secret is in materials, and particularly nanostructured materials that allow much greater density of energy at lighter weight and smaller volume. Another innovation is fuel cells. Again, nanostructured materials are key. We're trying to find a way to drive the cost down by taking the platinum catalyst out of these things. And there are a whole series of very promising ideas, again funded by the Recovery Act. These cells can operate in automobiles, but they also have a lot of stationary applications, and they certainly have a huge benefit in any place where you're operating in a closed environment and you can't tolerate any serious exhaust emissions. But capturing these opportunities in efficiency is going to require fundamental restructuring of the incentives for efficiency. There are enormous barriers that prevent people from making investments that are overwhelmingly cost effective. Plainly, one of the major actors has got to be electric utilities. In principle, if you can actually find a way to get so that they make as much money investing in energy services and efficiency on the demand side as they make investing in production on the supply side, you will drive a much more balanced investment, drive down the net cost of energy services. Saying this and doing this, however, is extremely difficult, as I'm sure you're going to be discussing further. But so if this problem can be solved, it's an enormous step forward, not just for residential, but for commercial and industrial retrofits. There are a variety of other policy ideas that we're moving forward. We have a lot of regulatory authority that we haven't fully utilized that we're trying to, and there are a lot of innovations as you may know, EPA has been given authority to regulate CO2 as an emission by the Supreme Court, and they are going to be they're moving out aggressively to regulate the emissions of vehicles. Now, at the end of the day, you're going to have some. You're not going to drive energy demand to zero. You're going to have to find some way of supplying the remaining demand. The baseline assumption is electric generation will go up and go up sharply over the next 30 years. One interesting question is if we start to we can drive down the energy consumption of buildings, but we're going to be maybe electrifying a lot of processes in industry and transportation. So there's actually an interesting argument about what the shape of this curve will look like in an aggressive, efficient, renewable driven economy. But electricity production is going to be a key, and there are a lot of interesting ways to take the carbon out of electricity. One of the advantages of having large centralized coal facilities, for example, is that the economics of taking carbon out of a centralized facility is a lot better than trying to take carbon out of the emissions of a lot of decentralized units. Now, the resource available through renewables is extraordinary. There's photovoltaics, solar thermal, wind, biomass, geothermal, and the theoretical contributions of these are many hundreds of gigawatts, in some cases thousands of gigawatts. Now, there's clearly a giant gap between the theoretical potential and what you can practically capture. We've got a number of policies in place to try to provide incentives, and we're, for the first time, having our loan guarantee program actually getting loan guarantees out to make some of these large-scale investments come alive. Walking through them briefly, biomass is, as I said, is a finite resource, as a billion tons a year, unless you can find some way to break out. One way to break out is to grow algae, and there's a lot of appetite for algae production. But interestingly enough, there are uses for algae and bacteria that aren't just growing the biomass, but using them as synthetic fuel converters. If you've got a sugar, you can ferment it to an alcohol, but these engineered organisms, or some of them are not engineered, some of them are just found in pond scum. You can do a remarkable job of getting them to actually produce hydrocarbons directly. So you're basically fermenting, instead of to alcohol, you're fermenting it into a hydrocarbon that can be blended in with gasoline or diesel with essentially no blend limit. And as you probably know, there's a dilemma of how high we can blend alcohol fuel with conventional gasoline without doing harm to vehicles that weren't originally designed for this. There are also pyrolytic thermochemical ways of using these technologies to generate a whole variety of fuels and feedstocks. Photovoltaics, we're taking a systems approach to this to get the price down from what it is now, about $8 a watt, down to $2 a watt. You got to look not only on the array, but the installation and the inverters and all of the balance of systems costs. Our boss, Secretary Chu, was quoted in the Washington Post last week saying that we were being wusses for only setting $2 a watt as a goal. He wants us to get to $1 a watt, so I got to go back and redo this graph and see how we're going to get there. But it's certainly either $1 or $2 a watt, this becomes an interesting there's a lot of opportunity both for siting these things out in high sunlight desert areas and integrating them into the roofs of buildings. And if you look at the learning curves, the kinds of goals we're setting are not preposterous. This is a sort of a classic innovator's dilemma curve in which you have silicon, which has been the dominant technology, getting better and better. In the recent years, we've, again, through this Stimulus Act, we've been able to get the silicon, volume of silicon you need for these cells reduced by factors of 3 and 4 by making the silicon wafers thinner. But the thin films are on a whole different curve, and they're already a company for solar that claims that its manufacturing costs are 80 cents a watt and on a steep decline. So these dramatic reductions I'm talking about are not science fiction. Again, through the Stimulus Act, we've been able to put resources on a whole range of fascinating new ideas. I mean, we got way more interesting ideas than we could fund. So that trajectory I showed you before is going to continue for years to come. Now, concentrating solar is another option. Here again, it's a question of driving down costs. Can you make a reflecting material that's cheap, can last in harsh conditions for 20 or 30 years? The answer seems to be yes. The whole series of firms, again, we funded through the Recovery Act, have come in with fascinating new materials technologies that seem to be up to that task. Wind is the biggest non-hydro renewable that we've got out there on a very steep cost curve. If you want to see these new, this is like I think a 3.6 megawatt machine. That's a 747. These are really, really big, terrifyingly big machines. I had to stand next to one dedicating it, and it is intimidating, let me tell you. One of the dilemmas here is reliability. They have complicated gearboxes. You want to make sure that they can operate for a long period of time with minimal maintenance. And again, we've gotten a variety of fascinating solutions to the roughly 2,000-year-old problem of windmills, where you have a rotating shaft that's rotating at 20 or 30 RPM, and you want to get some useful power off of it. We're starting a new initiative offshore. The dilemma here is that it costs you almost twice as much to build a machine offshore as onshore. and you really don't want to maintain these things if they're offshore. And the costs are driven by the fact that building stuff in the ocean is a difficult, dangerous, and now expensive challenge. There are, however, again, lots of smart people with really good ideas. We're able to fund some of them. I hope that we're going to be able to expand our program very aggressively in this area in the near future. I mentioned the cost of installation. There are also a lot of advances that we've been able to make in the design of the blades and clever ways of cutting the cost of manufacturing these blades. Again, cheap carbon fibers and cheap ways of assembling the carbon fibers. Hydro, there's probably at least 100 gigawatts worth of hydro we could get by either improving the technology on existing dams, which includes trying to find turbines that don't turn salmon into sushi, which is becoming an increasing problem. But there do seem to be blades that allow at least 90% of the fish through, and so there is hope. There are also a lot of dams that don't have power facilities on them, and we're trying to work our way through the regulatory process of seeing what it would take to get equipment put on there. A lot of them are on funny places like the Tennessee Tom Bigby Canal, which I guess has got a lot of water sluices and overflows that could easily be, or it appear to be fairly easy to trap with power equipment. Well, what I've gone through here is sort of the good news, which is that there is a lot of opportunity for productivity growth, for new technology, for innovation in the efficiency and renewable business environment. It's clear that this is an international race, however, and at the moment it's one where it's not clear at all that the U.S. is going to be the dominant player. You can see that we are slipping with respect to the Chinese sharply in not just bulk cheap exports, but in high technology exports, as they are not only producing, but learning and innovating along with their manufacturing. And it's showing up in renewable energy in very powerful ways. You can see that the whole U.S. production of solar has grown. Our market share has tanked. And the reason for that is pretty clear. There are huge markets in Europe and China driven by public policy, which dwarf what the U.S. is doing. So clearly, if you're a manufacturer and you look at this, you put your production plant and increasingly your R&D facilities where the action is. And it's unfortunately not obviously the United States at the moment, though plainly we're trying our darndest to change that. One interesting artifact is that there is a strong correlation between countries, this is largely Europe, but countries that actually have a stable and predictable energy framework. Some of them have more expensive energy, but it's predictable. And the predictability seems to be one of the key ingredients for allowing people to invest and innovate, because they understand more about what the future is going to look like. Whereas there's a danger that U.S. policy has been in a state of just sort of angry argument for a long time. We're hoping that's about to change. One of the things we have done, of course, is we have continued to invest strongly in renewable energy and efficiency. Our budget is roughly double what it was 5 years ago. And here's what we've asked the Congress for this year. As you can see, this is not what we've got, it's what we've asked for, but it's roughly what we got in our base budget last year. We're putting our money roughly where across the spectrum of activities that I just described to you. In many cases, the priorities within these are shifting as new opportunities emerge. But it certainly is a non-trivial investment in one of the largest research programs in the world. The Recovery Act increased our funding this year by a factor of 10, and one of the biggest challenges we faced was how do you take a sudden surge of money like this and invest it in a way that builds a sustainable capacity in the enterprise? In other words, can you invest in battery manufacturers that can find a stable and sustained market after our stimulus money goes away? Can we use it to stimulate the development of a retrofit industry and a financing mechanism that will endure after the initial stimulus goes away? The answer, we have thought a lot about this. The things that we've done, I think, have been
certainly short of perfection, but I think we can say with some confidence that we have in fact made a lot of strategic investments that will sustain themselves beyond the recovery. One of the things that, of course, we're aiming at very heavily is the production of jobs. And interestingly enough, this is another area where innovation is possible. Actually, North Carolina State, UNC, are the center of a lot of simulation and computer-based learning. A lot of it has been dominated by DoD. We're trying to get the DoD guys to help us understand how you can train lots of people in lots of complicated things and how do you certify them. And that's been an area, sort of an unexpected area of innovation, which has been an integral part of this recovery. But at the end of the day, the only thing that's going to work over the long period is we need some kind of a stable policy environment that will drive this forward. And there's legislation that's going to be introduced in the next couple of days, which I hope will be in the Senate, which we strongly hope will be the basis for bipartisan agreement on how to move forward in this area. There's a strong interest in trying to find ways of capturing the opportunity of efficiency and renewables as a part of U.S. innovation policy, as a part of U.S. job creation policy. I'm very confident that a bipartisan coalition can be built around that observation, which is strongly supported by a wide range of industry. And we're going to keep our fingers crossed in the next couple of weeks because we're going to find out.